So another important skill that we want to learn and to understand when it comes to geography is how to read and understand a climate graph. So in this set of audio notes today, albeit a short one, we're going to look and understand how to read and also how to construct a climate graph. So let's get started. To begin, we want to think about what is a climate graph. So climate graphs are a combination of a bar graph, which gives precipitation, and a line graph, which gives the temperature overall. Temperatures are always done in the red, and the temperature is shown on the line graph, with the figures being in 0 degrees because we are in Canada. The measurement for the temperature will always be on the left side of the graph. Rainfall is shown in blue for the rain, snow, essentially precipitation. And the rainfall is shown by the bar graph and the figures measured in millimeters, which is then measured on the right side of the graph. It is important to remember that both the temperature and the precipitation are averages done from one month to the next. Here is an example of a climate graph in the city of Edmonton, Alberta, Canada. As you can see, you have the two measurements, the precipitation in blue and the red for the temperature. Temperature is measured on the left-hand side in intervals of 5, and the precipitation is measured in 20 segments in millimeters on the right-hand side. Other additional organizational points is that every month, January, February, March, April, May, June, July, August, September, October, November, and December are laid out one at a time in the correct chronological order. But to keep the graph from not being messy, we just put the single letter for each one. You'll notice too that it is only in the months of June, July, and August is when you have the best growing season because of the amount of precipitation and the average daytime temperature being over 0 degrees, essentially the freezing level. Everything else tends to be too cold. Additionally, you might notice in the months, as an example, in February, March, October, and November, there's not a lot of precipitation, but the temperature does get quite a bit colder, which usually means there will be a lot of snow on the ground. One thing you want to know and to be able to tell when you're looking at climate graphs is that you want to predict patterns. That is really the main goal, being able to predict the patterns, whether it's for what type of clothing should be worn, the weather, or growing season, etc. When you are interpreting climate graphs, as I just previously mentioned, but to reiterate, you want to look for patterns in the temperature data. Some of the questions that you can use to ask yourself when you're looking for patterns in the temperature data is first, is the temperature the same year-round? And if it's different, when are the summer months, when it's warmer, and when are the winter months, when it's colder? But would you classify summer as cool, warm, or hot? Some places, it's not always summer going to be hot. Example, in the southern hemisphere. So you want to watch for those kind of details and where the country or location is located. Additionally, you want to classify, would you classify winter as mild, cold, or very cold? Once again, you want to look at the precipitation and the overall average temperature, the high and the low, to get your answer. Followed by, what is the range of temperatures? And how you create the range of temperature, so you average out the usual daytime high and the daytime low. You want to subtract the minimum temperature from the maximum temperature to get your overall average for the month instead of day by day. If we do a practice here with Victoria, British Columbia, the provincial capital, once again you can see the temperature indicators on the left, the precipitation on the right, but Victoria is a much warmer city than Edmonton, so the 0 degrees, the freezing level, that measurement is on the bottom of the graph instead of halfway up as it was with the Edmonton example. And because of that, the markers of January, February, March, April, May, June, etc. are at the bottom instead of at the midway point. But if we're looking at patterns, you can tell from the months of April through to potentially October, you have a greater growing season. As a pattern, it's warmer in Victoria and there's less precipitation. However, in the months of January, February, November, and December, even though it is not below 0, it is still cool, but there is significant amounts of precipitation, which usually means it is rain. So the growing season is not as much, and you definitely would want to bring umbrellas and rain gear if you go to Victoria during those months. But it also means it can be cheaper to travel there because of, well, the rain. When you are also interpreting climate graphs, like you do for precipitation or for temperature, for precipitation, you also want to look for patterns in the rainfall data. And some of the patterns you want to look for is first, does the rainfall occur yearly, year-round? Or do some months have more precipitation than others? For the seasons, you want to figure out which seasons are drier and which seasons are wetter based upon the average amount, and what is a total annual amount of rainfall. And you get this by adding together a total of each one, like this for Victoria. And how you put it all together, you put the rainfall, temperatures, and freshen together, and that will give you a working idea of what to expect for whatever location, geographical area, city you're looking at going to.